Hey, welcome to my channel. My name is Dr. T. Swapna. We are studying digital signal processing. Today's topic is discrete time Fourier transform. Discrete time Fourier transform is the Fourier transform of the discrete time signal. Discrete time signal can be represented in frequency domain by using Z transform or by using DTFT. So the Fourier transform, we call it as a discrete time Fourier transform. In time domain, we represent the discrete signal with x of n, and in frequency domain, we represent with x of omega or x of e to the power j omega. So the definition which is given by x of omega or x of e to the power j omega equal to summation n equal to minus infinity to infinity x of n e to the power minus j omega n. This equation we can also call as analysis equation because we are analyzing what are the frequency content in a given discrete sequence. Similarly, the inverse DTFT is given by the equation 1 by 2 pi integration minus pi to pi x of omega e to the power plus j omega n d omega. Now why integration? Because x of omega is continuous as well as periodic in nature in frequency domain. So that's why we are using the integration. While in time domain x of n is discrete, so we use summation. In frequency domain x of omega is continuous and periodic. So this is a synthetic equation. So here we have seen these two equations, analysis equation which is a DTFT equation, synthesis equation which is a IDTFT equation. Then we have to see what are some conditions for existence of DTFT. So the most important condition for existence of discrete time Fourier transform of any discrete sequence x of n is the sequence should be absolutely summable. That is summation n equal to minus infinity to infinity mod of x of n should be less than infinity. If the signal is absolutely summable, then only we can able to obtain the DTFT of that signal. Also, if a sequence is exponentially decaying, that is a to the power n u of n. If the signal is decaying, we can obtain its DTFT. But if the signal is exponentially increasing, we cannot obtain the DTFT because it will not be absolutely summable. So that is one thing. Similarly, the difference between Fourier transform and discrete time signal and analog signal are: first, the Fourier transform of analog signal consists of the spectrum from minus infinity to infinity, whereas the Fourier transform of the discrete signal will be periodic in the range minus pi to pi as well as it is continuous in domain. So all that is, the Fourier transform of discrete time signal is periodic and continuous, and period is 2 pi. Now we will see the DTFT of some basic signals, basic elementary signals. First is unit impulse signal. As we know, unit impulse signal is defined as x of n equal to delta of n, where delta of n equal to 1 for n equal to 0 and 0 for n not equal to 0. Now we will apply the simple DTFT formula, which is summation n equal to minus infinity to infinity x of n e to the power minus j omega n. Now x of n is delta of n. So delta of n exists only at n equal to 0. Hence from minus infinity to 0 and 0 to infinity other points are 0. Hence we can apply at n equal to 0, e to the power 0 will be 1. Hence the Fourier transform of the impulse signal is 1. So sometimes the small question can be asked, what is the Fourier transform or DTFT of an impulse signal which we obtain as a 1. Then coming to the next signal, that is unit impulse signal, x of n equal to u of n. Unit impulse signal is defined as u of n equal to 1 for n greater than 0, greater than equal to 0 and 0 for n less than 0. Again applying the basic definition, summation n equal to minus infinity to infinity u of n e to the power minus j omega n. Now according to the definition, u of n exists only for n greater than 0, hence the new limits of the summation will be 0 to infinity e to the power minus j omega n. Now this expansion we can write as 1 divided by 1 minus e to the power j omega. Hence, the Fourier transform of or DTFT of u of n is 1 divided by 1 minus e to the power minus j omega. Then next, DTFT of exponential signal. Now, the discrete exponential signal is given as a to the power n. Here we are considering the single-sided exponential signal, right-sided exponential signal. That is x of n equal to a to the power n u of n. Now again applying the basic definition, minus infinity to infinity. A to the power n u of n e to the power minus j omega n. Now u of n is 1 for n greater than equal to 0. Hence the new limits will be 0 to infinity a to the power minus j omega to the power n. Again by applying our basic formula, that is summation n equal to 0 to infinity x to the power n, we can write it equal to 1 divided by 1 minus x, where x is less than 1. So similarly we can write here summation n equal to 0 to infinity a e to the power minus j omega to the power of n will be 1 divided by 1 minus a e to the power minus j omega. So this is a DTFT of the exponential signal. Then coming to cosine signal. Now cosine signal we are defining by cos omega naught n u of n. Again single-sided cosine signal. Again applying the definition, minus infinity to infinity x of n into power minus j omega n. Cos omega naught n, I can write it as a e to the power j omega naught n plus e to the power minus j omega naught n by 2. Then separating the summation side and writing this expansion. So when you solve this equation, we will get the final answer as 1 minus e to the power minus j omega cos omega naught divided by 1 minus 2 e to the power minus j omega cos omega naught plus e to the power minus j to omega. So this you can remember or you can solve it. So this is a reduced form of the equation. This is the DTFT of a discrete cosine signal. Similarly, the discrete sinusoidal signal, applying same formula, summation equal to minus infinity to infinity x of n e to the power minus j omega n. Again, as it is the right-handed signal, new limits are 0 to infinity, and we solve this. The final answer we will get e to the power minus j omega sin omega naught divided by 1 minus 2 e to the power minus j omega cos omega naught plus e to the power minus j to omega. This is a discrete Fourier transform of sinusoidal signal. Similarly, we will solve some examples. Just try to solve these examples in your free time. Obtain the DTFT of the basic signals. These signals by applying the basic definition. If you find any difficulty in solving this example, please let me tell in the comment section. Thank you.